supposed to verify that each is an identity, which means make the left side and the right side the same thing. For this problem, I would change cosecant to 1 over sine, cotangent to cosine over sine, and tangent to sine over sine. So basically what I'm saying is change everything to terms of sine and cosine. You notice in your denominator there's two fractions you're supposed to add. So get common denominators in your denominator and add them. To do so, in the first fraction, would multiply the top and the bottom by cosine. Gives you cosine squared on the top, gives you sine times cosine on the bottom. On the second fraction, multiply the top and bottom by sine. Gives you sine squared on the top, and it gives you sine times cosine on the bottom. Once you have common denominators, then you add your fractions, you add the numerators, leave the bottoms the same. And we have a complex fraction, which means a fraction on top of a fraction. We've had that this whole time. At this point, I would change it to be a simple fraction. Once the numerator is already simplified, which it is, the denominator is already simplified. So you take the numerator and you multiply it. Well, I guess before I do that, I'm going to simplify cosine squared of x plus sine squared of x. Make that 1. Now I'm going to make this a simple fraction by multiplying the numerator by the reciprocal, that means flipped over, of the denominator. Notice the signs cancel on the top and bottom. You're left with cosine of x equals what the right side was all along, cosine of x. Number 2, this is a very complicated problem unless you recognize that you can factor the left side. It's a difference of 2 cubes. Difference of 2 cubes factors like this. In the first set of parentheses, you take the square root of the first term minus the cubed root of the first term minus the cubed root of the second term. And in the big set of parentheses, you take the first term's cubed root squared. So cubed root of sine cubed is sine. Square it, you get sine squared. And you add to that the two middle, this cubed root of the first and last term, so sine of x, cosine of x. Then you add to that the cubed root of the last term squared. The cubed root of cosine cubed is cosine. If you square that, you get cosine squared of x. This is all in your factoring sheet in your notebook. Please look at it right now if you haven't done so. Then you'll see that we have sine squared of x plus cosine squared of x, which of course is 1. Now if you look at the left side of the equation, compare it to the right side, it's nearly identical. We just have our sets of parentheses in the wrong order. You can switch those around because the commutative property says you can multiply in any order. Now the left side and the right side are the same. We're finished. Number 3, I see 2 fractions I'm subtracting. So I would want to get common denominators and subtract those 2 fractions. The first fraction, I'm going to multiply the top and bottom by sine of y plus 1. Second fraction, I'm going to multiply the top and bottom by sine of y minus 1. That gives me common denominators. Make that one fraction. I want to be careful, since I'm subtracting, and there's more than one term on the top, I'm going to put the first numerator in parentheses minus the second numerator. So we're subtracting, which is the same thing as adding inverses. So I'm going to add negative sine of y, and I'm going to add 1. It gives us 2, because sine of y plus negative sine of y is 0. 1 plus 1 is 2. And our denominator, we can multiply those using the FOIL method and get sine squared of y minus 1. You can finish this in several different ways, but when you get stuck, because right now I've been on autopilot, I haven't used any identity. I've simply subtracted 2 fractions. I look at what I have on the left and what I'm trying to get. I'm trying to get a 2 on the right, which I have. It's great. I'm trying to get a secant on the right, which I don't have. I know that secant and cosine are related. So I need to get cosine in this problem somehow. Well, I know the Pythagorean identities. I know that 1 is the same as sine squared of y plus cosine squared of y. So I replaced that 1 right here with sine squared plus cosine squared. There's different ways you could accomplish what's happening here. That's just one way. If you combine like terms, if you get rid of this subtract to make it plus, distribute the negative, You have sine squared of y minus sine squared of y. That cancels. And you have negative cosine squared of y. Now we're cooking. Cosine squared of y, its reciprocal is secant. Now it's the same thing that the right side is. Done. Number 4 is another problem that if you recognize that factoring can be done, this problem is real simple. The left side is a perfect square trinomial. First term is a perfect square, last term is a perfect square. If you multiply those square roots together and double it, you get this middle term. So this factors into 1 minus sine squared of r squared. This is the square root of the first term. This is the square root of the last term. This is the same sign as the middle term, and that whole thing is squared. That's also in your factoring sheet. Please get it out right now and look at it if you have not done so. 1 minus sine squared is the same thing. Well, once again, different ways to do this. It's not the way I did it when I started to say. I'm going to change 1 to sine squared plus cosine squared. It's Pythagorean identity. Notice now the sine squareds are going to cancel because you're adding 1 and subtracting 1. Leaving you with cosine squared of r squared. Power to a power property, you multiply the exponents, you get cosine to the 4th, which is what the right side was all along. Number 5, I would get everything in terms of sine and cosine. And I'm going to get common denominators. The left fraction needs to multiply the top and bottom by 1 plus sine of u. The right fraction needs to multiply top and bottom by cosine of u. Once you have common denominators, I'm going to multiply to distribute this out. Distribute cosine times cosine. It's not distribute, it's just multiply. Denominator, I'm not going to multiply it together. You'll see why here in a minute. You might not know that. You might multiply it together, but you don't need to. Sine squared plus cosine squared here, once again, is 1. Notice what happens. You can cancel a sine of u plus 1 from the top and the bottom, giving us 1 over cosine of u, which of course is secant, which is what the right side is. Number 6, I would change everything into terms of sine and cosine. Not the only way to do the problem, but it works out lovely for this one. I also took the liberty of changing this cosine to get common denominators with these. So this is cosine over 1, multiply the top and bottom by cosine, you get cosine squared over cosine. Combine your fractions, sine plus 1. The numerator and our denominator, we got 1 minus cosine squared plus sine, which is what this is all about down here. Then, instead of having a complex fraction, multiplied by the reciprocal of the denominator. I forgot this x here earlier. I just put that in. You see there in green. Cosines cancel on the top and bottom. Also notice that this 1 minus cosine squared of x is the same thing as sine squared of x. That's a Pythagorean identity. You can factor out the denominator, sine, it's GCF, and you can cancel a sine of x plus 1 on the numerator and denominator, so you get cosecant of x equals cosecant of x. Number 7, find a numerical value of one trig function of each x. Your answer is when you have one trig function on one side and a single number on the other. If you divide both sides by cosine here, sine over cosine is tangent, so you get tangent of x is 3. That's one answer. There are 5 other answers that are also correct. Check out the answer key if this is not the answer you got. Number 8, if you change cotangent to cosine over sine, then multiply both sides by the reciprocal of cosine over sine. On the right, your cosines cancel and your sines cancel, so there's just a 1 left on the right. On the left, your cosines cancel, so you get sine of x equals 1. Once again, that's one answer. There's 5 other answers that are correct as well.